showcase me running through 32 images with my integrated gradients. We'll go ahead and do two tests, one with a blur baseline and then one with a black image as a baseline. So for reference, this is like a test image for one image, and then this is our function blur, down up blur, so we make it small and then we make it big. This is the output of that function. And then this is kind of when we run integrated gradients on it. So right here, this is just saliency, original image, saliency, blurred image, or blurred image with a baseline. So the baseline for the integrated gradients is this blurred image right here. And then that is the corresponding attribution map. This one is with the black image, the black baseline. So just, you can think about like a black, just a complete black image. Furthermore, we will just go ahead and go down here. This is me looping through the 32 images in the beginning up here. So we're going to be looping through all these images. We will first do it with blurred baseline. So a blurred baseline right here. We call the function input, and we call the baseline. And what it's going to show is it's going to show the original image, the blurred baseline, and then the true remap label, the original class, and then the class predicted by the model. I think we will actually just go ahead and do this all in one. Here, copy and paste it, and we will take, oops, go right here. Make this 2, result to me. And then we'll go ahead and do this, copy and paste this. And it's the result, we'll show result 2. And this will be not blurred. So what it's going to look like now is we're going to see the blurred baseline, and we're going to see the black baseline. Make sure we actually do this right. It's not going to be baseline, it's going to be baseline times 0. So baseline times 0 is just going to give us a black image in return. And then we should go ahead and be able to run this and get our results. I think when I did train the model, I did around 80% success rate. And I think, let's see, our test loader, can you see how many images it is? I want to say it's about 10,000 images. But yeah, 80% of 9,000, about 7,200, so it should, I guess, correctly classify about 7,200 images out of the 9,000. I can hopefully do math correctly. 6% says that's right. But yeah, we'll go ahead and start at the top and then work our way down and see what it thinks. So, original image, we have our corresponding remapped labels, mountain, then the predicted class by the model, and then the blur baseline, then black baseline. And I'm just going to go ahead and keep going. I'm going to stop at some that I think are interesting. Specifically, wait for a line. Like right here, this one is actually incorrect, so that's interesting. The predicted orchid, but it's actually a tulip. And this doesn't indeed look like a skunk, but it predicted skunk, but it is actually a butterfly. I really like this one. This one is a line right here. I like this one as well. It's very understandable. I think going down here, I think it did incorrectly guess another one. We'll see when we get there. right here. It's obviously a rose. Original class is rose, and then maple tree. This is maple tree. Quite interesting. So I guess the thing is when we train our classifier, don't know how this thing gets long. I mean, don't know how this thing gets telephone. Maybe I withheld. No. Oh, same thing with this one. Guessed flatfish instead of turtle. Which I'm quite surprised about that.